Now we're going to talk about vertical asymptotes. Remember in class we said a vertical asymptote is like a wall. The graph is going to approach this wall. It's going to hit against it. That doesn't mean it touches it or crosses it, because you know vertical asymptotes we don't touch or cross. But it's like if we smashed against the wall and the graph either pushes up or pushes down against this wall. So we're going to find where these walls are on the graph. And the way we do that is we look at the denominator. And the denominator you have seen so far that plays a big role in rational functions because they tell us the values that are not valid. They tell us where the vertical asymptotes are. They tell us about the domain. And they're also going to talk to us about holes in our functions. For now, we're only going to talk about vertical asymptotes. It says here that I have to find the zero in the denominator. And if you already found your domain, you've already found your zero. This is why when we look for domain, we set our denominator equal to 0, right? That's how we find our domain. We write x minus 1 equals 0, and we solve for x equal to 1. And if you write your domain, you would say, well, the domain is going to be all the numbers in the real number system except x equal to 1. There you have your domain. When we want to find vertical asymptotes, I do the same thing. I take my denominator, I equal it to 0, and this tells me this is a possible vertical asymptote. Possible. Why do I say possible? Because I have to be careful. I have to check if this x makes my numerator 0. Okay? So this will be a vertical asymptote only if it doesn't make my numerator 0. So let's check. If x is equal to 1, I'm going to check in my numerator. So I'm going to plug in 1 squared. I have 1 squared minus 1 minus 2. 1 squared is 1. 1 minus 1 is 0. And 0 minus 2 is negative 2. That checks out. It didn't give me a 0 in the numerator. So that means that this is no longer a possible vertical asymptote. It is the vertical asymptote, and it happens at x equal 1. Okay, so let's go over that again. To find the vertical asymptote, we take the denominator, we equal it to 0, we find x, which you might have already done when you were finding the domain. X equals 1. That is where I have a possibility of having a vertical asymptote. So how do I make sure if it is? I take this x equal to 1, I check my numerator, I plug it in. If my numerator is not 0 when I plug this 1 in, that means that this is a vertical asymptote. If I plug that into the numerator and I get a 0, that means that that x makes the numerator and the denominator 0, both of them. Then I have to further investigate to know if it's a vertical asymptote or a hole. It can be one of the two, okay? But in this case here, I've checked it in the numerator. I did not get a 0. That means this is in fact a vertical asymptote, and it occurs at x equal to 1. That means when we start sketching these functions, at the value x equal 1, I will have a vertical asymptote that looks like that, a dashed line. That's my wall, okay? Let's see the second example. F of x is equal to this. I want to find the vertical asymptote. I take my denominator. I equal my denominator to 0, which you probably already did when you were finding domain. But since I don't have it here, I'm going to go ahead and do it. So x is equal to 4. Now, what we do is we say this is a possible a possible vertical asymptote. Not sure yet. How do I make sure? I plug this x into the numerator and I evaluate. If I get a 0 in the numerator, then that means I can't say for sure if it is a vertical asymptote or not. Okay? And in my next video, I will explain how to determine if it is or not. So let's plug 4 in. If I plug in a 4, I get 4 squared minus 16. That makes 16 minus 16. That makes 0. So notice how I get a 0 in the numerator and a 0 in the denominator. That means right now I don't know if I'm going to have a vertical asymptote at x equal to 4. How do I know? How will I find out? Next video I will show you how. Now another thing I want to say before we move on is, on my last video I was talking about how some people, the first thing they did with the rational function was factor it out. And it's a good idea for this step to factor out your function, because now we need to see the multiplicity of the zeros. When this case happens, I need to see the multiplicity of the zeros to determine if it's a vertical asymptote or if it's a whole. So it's convenient to have it factored out. You can leave this function as is for the first couple of steps, for finding your domain, for finding the x-intercepts, the y-intercepts, the vertical asymptotes, etc. But when you're determining if it's a whole or vertical asymptote, you're going to need to factor it so that you can see the multiplicity of the zeros. You can do that right at the beginning if you want to, or wait till you get to the step of finding vertical asymptotes so that you could see the multiplicities. Okay? I will see you in the next video when we talk about wholes.